Welcome back, scientists. Today we're moving into the explore phase of our project-based learning unit. Our big challenge is to design a better water bottle using real tests, data, and of course, scientific thinking. So in our last session of our 5E project-based learning unit, we were on the first E, which was engage, and now we're on explore. But to recap, what we learned in engage is that we watched a short video talking about the problems with water bottles, how they clutter up our environment, how they are bad for the environment, and how they just aren't that great, these plastic water bottles, at keeping your water cold or a liquid hot in case you wanted something hot in here. It's not good for either of those purposes. And of course, it's just asking to be thrown away for that reason. It's just not very useful. So how can we build a better water bottle was what we were looking at. And when we were investigating that, we had some great questions that you asked. Some of those questions were, why do some bottles leak? What keeps some water bottles colder while others don't keep as cold? And we used those real engineering questions to put on our Wonder Wall, which is a collection of the questions that we'll be investigating today. We also talked about in the Engage lesson about the concept of durability, insulation, absorbency. Some of these words that we've known and covered in previous science units, and some that are new, like insulation and thermal conductivity. We'll be using those words and learning more about them today as we conduct our tests. So let's just get into that. But before we can start testing materials, there's something really important we need to do. We need to know what we're testing for. What we're testing for is what we're going to be graded on when we present our final project. And what that is we call that criteria and restraints. Criteria and restraints are like the bounds of our experiment. It's where we can go and where we cannot go. And it specifically, because you're being graded on these criteria and restraints, you definitely need to make sure that you're within those bounds. What are the bounds? Okay, well, first off, your water bottle needs to hold 250 milliliters of water and not leak. So it has to hold about 8 ounces of water and it cannot leak. If it leaks, it does not meet that criteria. It has to use at least 2 of the test materials. We're going to talk about the test materials coming up. You need to use at least 2 of them in your design. It needs to be easy to carry, weighs less than 1.5 pounds or 1.5 pounds or 1 5/10 pounds. It needs to be that light because water bottles need to be pretty light if we're going to carry them around, and you need to be able to pick it up and hold it with one hand. That's what we have decided is going to be deemed as portable. If it can meet those requirements, meet those criteria and restraint, then it's portable and it serves as a water bottle. And then of course it needs to be in budget. It can be no more than 10 material units from the store. The classroom store is where we're getting all of our materials from. This can't be any more than that. It cannot be any more than 10 materials. So you'll need to think about which materials you want to use and use them sparingly. And then lastly, it doesn't break when dropped from shoulder height. That's its last test for durability, or its final test is can it survive being dropped, which of course we know water bottles are dropped all the time. So now that we know the bounds of our experiment, we know the criteria and the restraints, what we can and cannot do, what we need our water bottle to do, and what we need it not to do, we're going to talk about how we're going to test our materials so that we can design the best water bottle. So you're going to explore the properties of materials at 4 testing stations. Each station will give you a chance to collect the data and learn something new, and hopefully answer some of those questions that we have on our wall. First up is the water retention station. You're going to test which materials absorb water and which ones repel it, or which ones don't absorb water. And then there's the heat conductivity station. You wrap warm water bottles in different materials and record how quickly the temperature changes. Next is the durability station, when you're going to bend, scratch, and apply pressure to test strength and flexibility of materials. And finally, the weight station is where lighter materials are easy to carry, you might think, but they might not also be that strong. So we're going to weigh our materials and figure out if we hold their volumes the same, I mean the size, the area they take up which one weighs the most, which one weighs the least, and we'll use that to help us make decisions. But before we can break into our groups and jump into our stations, we need to talk about the materials we're going to be testing. And here they are listed. We have plastic, cardboard, foil, cloth, styrofoam, rubber, wax paper, aluminum, bubble wrap, felt, and cotton balls. You'll notice that these materials are already provided to you at the stations, conveniently arranged to best fit the requirements of that station. So the first station is the water retention station, and at this station it's your job to test how materials respond to water. Take a dropper and gently place the water on the samples like wax paper, felt, foil, or cloth, whatever it may be. You're going to do that with all of them. All the materials are going to go through this test, and you're going to answer the question on your data sheet for that station. Do they absorb water immediately like cotton balls, or do they stay dry on the surface like plastic? And use our classification system to classify them as either waterproof, means the waterproof rolls right off, water resistant means it takes a while to soak in, and absorb, it means it soaks up right away. You're going to record those classifications in the chart, and then think which one you would want to use as the outside of the bottle, which one you want to use as the inside of the bottle. Now it's time to test insulation. This is arguably one of the most important tests we'll be conducting, and that is to take 4 of the pre-warmed water bottles at the same time, wrap each in a different material. Each partner should wrap a water bottle so they all start cooling down at the same time. So you want to wrap all of them at the same time so they start cooling down at the same time. All of the materials are easy to wrap around. I've arranged them so. Then you're just going to place a thermometer in each one and take a reading every 5 minutes for 15 minutes. As the time passes, you'll see that some bottles will lose their heat faster than others. Insulators will lose their heat slower than others. When your data on a line graph, or graph your data on a line graph in the recording sheet, and then look at the trend. We talked about trends in math before. Which material slowed down heat loss the most? The data will help you pick materials that keeps your water the right temperature. And now, so the durability station. Imagine your water bottle falls into the ground. What kind of material do you want it to be made out of? At this station, that's what you'll be testing. How strong and flexible the materials are. So you're going to try bending them and pressing on them and gently scratching the surface with a tool. We don't want to rip them apart. We don't want to do things like that. We don't want to throw them around. We just want to test them based on pulling, bending, pressing, gently scratching, things like that. Then we're going to drop them from shoulder height in the designated area and find which one would be the best for our water bottle. We're going to rate each of the materials from 1 to 5 and write a short explanation about how durable we found it to be. Remember, something can be lightweight but still fragile. Others might be strong but heavy. In this test, the weight station, you'll measure how much each material weighs. So each one is, like I said before, already measured out to have the same volume. Each material, you're just going to use the triple beam balance, to weigh those equal sized samples. Record each weight and think about how the weight would affect your final bottle. You want it to be easy to carry but still strong enough to hold water and be resistant to heat. So would you want your super heavy material if it insulates well, or would you trade some insulation to make it lighter? These are the decisions that engineers make every day. And then before we move on to the next E, we need to do the designing. That's where we're going to take we're going to make some decisions based on what I've learned. I want each of you to rank your top 5 materials and then which material performed best based on the criteria: water resistance, insulation, durability, and weight. You're going to use your test data and group discussions to help you decide. Don't just pick your favorite. We're going to use evidence for each material. Write the property it performed best in and what part of the water bottle it might be best used for. So maybe bubble wrap is great for insulation, but not for the waterproof part of the water bottle. So you might use it on the outside, but line the inside with something like wax paper, for instance. So this ranked list will become the backbone of your prototype design. So take your time on it and make sure it's thoughtful. Before you start any of this, I'm going to have you write down your predictions for which material you think is going to perform the best in each of those four categories in your journals. Thank you so much, and we're just about to get started.